In this window of the AVETO.dps user interface, you can see the configuration of the devices. In this demo setup, we are working with a Datalinx ATX4 with 64 CPU cores and 128 GB RAM. The 4 cartridges used, which are connected in parallel, are displayed here. It is possible to monitor the cartridges in parallel in an SMB share during recording, more on this later. This system is configured so that we record a total of 96 data streams. At this point it is possible to view the individual configurations. We have pure Ethernet traffic, we record the data on different storages. Here you can see the first storage cartridge that we are recording. If you scroll down you will find the other storages. The data is now distributed to these 4 disks of the 4 cartridges in parallel. You can see these 96 data streams again. We now switch to the dashboard, where we immediately find these streams again, as well as the expected data rates of 240 megabytes per second each. The statistics in the dashboard provide an overview of how many data packets arrive in total, how many packets arrive per second, but also how many errors occur per second, both during writing and data distribution. This video focuses on the data writing, so recording nearly 200 gigabit data rate to the disk. Here is a detailed list that can be scrolled down. At the end, the total amount of data which must be written without errors, in this case, 23.04 gigabytes per second. Here in the writer section we can also see when errors occur, either per data stream or in total. Below you can see in detail the errors that now happen per Ethernet interface, as well as the packets that are arriving at the Ethernet interface. Here we split again into individual synchronized files. The reason for this is that we are so able to write in parallel with much better performance and achieve much greater efficiency. In the next step, we will fire up our demo system with a data generator, as this will clearly show which packets are actually arriving. To do this, we first switch to the run phase and start recording, which activates the data generator. The startup phase of the synthetic data generator can now be observed. You can see how it ramps up and the data arrives at the various data streams. It is clear to see that all data streams are green, because this means that 240 megabytes per second, plus minus 10%, are now arriving and, more importantly, that they are being written and distributed without errors. The data rates of 23 gigabytes per second can also be seen very clearly. This fluctuates slightly up and down, which is due to the buffering of the data and is a completely common process. Once again, everything in the green zone, so to speak. At this point you can see also the amount of data already recorded for each individual 100 gigabit Ethernet interface. During this screen capture, the amount of data is already rapidly approaching 1 terabyte. It is also clearly visible that no errors occurred, meaning that no data packets were lost. Ignored means that a packet arrived that was not defined as such. This is not because we say, okay, we don't want this. In this case the configuration is not set like this. It can be assumed, for example, that a data packet was provided with an incorrect VLAN ID, which is then ignored and not written to disk. At the same time, you can see on the SMB share and here that a new folder has been created by the recorder. In this folder, we can also see how the data rates are increasing. We split the files again so that the files do not become infinitely large and are therefore much easier to handle. We have configured our system in such a way that a new file is created every 30 seconds, so that it is easy to watch in real time how the data arrives and the file sizes increase. We will soon have reached 2 terabytes. With the size of the cartridges used in our test setup, the maximum capacity of these will soon be reached. Of course, a much longer time can be recorded with larger cartridges. The data stream is now finished. Works as planned, a flawless performance has been recorded.